Okay, question 26. On the set of axes below, graph g of x equals 1/2 x plus 1, and f of x equals 2x plus 1 on the interval when x is less than or equal to -1, and f of x equals 2 minus x squared on the interval when x is greater than -1. How many values satisfy the equation f of x equals g of x? Explain your answer. Use evidence from your graphs. So the first thing I want to graph on my calculator, 1/2 x plus 1. So open a TI Nspire graphing calculator. So home screen, new dot, say no, add a graph page. So 1/2, control divide, 1/2 x plus 1, and enter. This is my first graph. Now again, I'm going to do menu 5-3, set my trace step to 1, and then menu 5-1. And my graph trace, if I come to the left-hand side of my graph, so as I work my way to the right, I would hope you would notice that we're going up 1 and right 2 every time. So we go right 2, up 1, right 2, up 1, right 2, up 1, all the way to the other end of the graph. And we end up at 10/6. So now I can graph my piecewise function. So press tab, we get another command line. Now we need the piecewise template. So next to the number 9 key is the template key. The piecewise is the one with the open bracket, but it has the commas to set our parameters. So this is the second function I want to graph. So my first rule says 2x plus 1 when x is less than or equal to 1. So 2x plus 1 when x, remember, control followed by the equal sign to get our less than or equal to 1. Now, the next rule for the second piece of our function says 2 minus x squared when x is greater than 1. So 2 minus x quantity squared when x is only greater, so no equal sign this time, just greater than 1. And now we press enter. So notice my blue graph, I'm done with that. So if I press tab, arrow up, I can turn that graph off. And now I'm just focused on getting this graph onto my paper. So menu 5-1. We already set our trace step. So notice 0-1 is a point on my graph. If I arrow to the right, my maximum is 1-3. So I'm going to start at 1-3. So 0-1. Then I've got -1, -1, -2, -3. So I'm going left 1, down 2 each time. -3, -5. So notice when I label all my points, draw my lines in, I've already established that the point 0-1 is a point of intersection for these two graphs. So I definitely have one value of x so far that is on both graphs. I want to find out if there's a second one. So when I look at a piece of our other function, Notice that it won't even make the jump down to 1, 1. Technically, 1, 1 is a point on the graph, but it's not a starting point because that's 2 minus x squared, and that's an open circle. So again, with a piecewise function, you can't have two x values be the same. So when x is 1, it's definitely up here at 1, 3. But notice, I can't ignore all this space between x equals 1 and my x-intercept. So I have to put an open circle at the point 1, 1 for this graph to be correct. So if I press tab, go back up and turn back our original graph, notice that that graph does not touch our piecewise function here. So the only place these graphs meet are at the point 0, 1. And that's understanding that there is a gap between this point and the point above. So they only have 1 point in common. So due to the break in the piecewise function at x equals 1, these graphs only intersect at the point 0, 1. And that's 4 complete points for question number 26.